Okay, so we looked at the planets and we had a protocol there and we had a category there. And I mentioned we could use them together, and that's exactly what we're going to look at in this one. So we're over in Logtalk Examples again, and this is the car engines example, which is perfect to follow up from the planets example. It's just like every other example, there's a loader and the tester. So let's get that loaded in the typical way, logtalk minus s loader, and let's take a look at our car engines here. So in this, we have a protocol for a car engine, and in order to be a car engine, or if it implements this protocol, it should give us a reference. Don't know what that's for. It's probably like some ID thing. Capacity, some cylinders, a horsepower, RPM, bore stroke. I'm afraid I don't know enough about car engines to fully grasp the meaning behind all these terms. And fuel, I know that one. I don't put petrol in my diesel car. So we've got a protocol. We know that doesn't come with behavior. It's just documenting the predicates, and these ones are all public ones. And then we have some categories, and they implement this protocol. So now we can actually have some behavior in here in our category in our it's category, so protocol doesn't get the behavioral stuff in or the facts in, whereas the category can. So for our classic car, if something imports the category classic, then it will have this reference and it will have, these facts as set. And we have another category as well following up, which is a sporting one, and it extends a classic category. Now this is exciting. So that means if it extends the classic category, it must implement the classic car engine protocol, which it does. But in extending, it can overwrite things as well. So we've only got two, 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 two things overwritten here. The reference is overwritten, and the horsepower (RPM) is overwritten to be this calculation where we get the horsepower (RPM) from its supercall. That's what the double two hats means. So like a supercall, so it's calling this horsepower RPM. It gets that's the classic HP and the classic RPM, and it truncates a multiplication of those numbers. All right, so let's have a little look, see what's going on. We've got two kinds of cars, two car objects defined then. One of them is importing classic, one of them is importing sport. So let's take a look at the sedan first, because that's just a classic without the whole crazy sport extension going on. So if it imports classic, then its reference must be public because it imports the car engine protocol, and it should be that M180 940, which it is. That's good news. And horsepower RPM, that's the other one to look at, right? So horsepower, I can spell RPM. What's that going to be? Predicate declaration. Horsepower RPM does not exist. Have I spelt it wrong? Sedan. Horsepower RPM should exist unless I'm missing something obvious. Yes, I am. It's arity 2 and not arity 1, right? Because there's the horsepower and then there's the RPM. Oof, oof, scared me for a second there. Alright, I thought it should work. So Sedan is working as expected. It's just returning those values. Now things get exciting with the sport. So rather than Sedan, it's a coupe, which imports the sport one. So this horsepower RPM is still arity 2. It's still horsepower, still RPM. Uh, and they are much, well, the horsepower is a much bigger number, the RPM is a little bit lower. This is what it's doing. It's getting the 94 and the 480 out. So let's just do one of these manually just so we can make sure this is right. So truncate. The classic HP was 94 times by 1.23, and it's 115. So that is doing exactly what we expect. So there's a little bit of a thing to trace there with your mind. You're gonna have to go and think through this, because the coupe with its reference is going to be getting this reference just straight from the sport that it imports. So that should be the one ending with a 1. Yeah, M180941. But when it comes to and if it would go to some other thing like cylinders, right? Coupe cylinders. cylinders. That should be 6, right? Let's just make it say true. Way. So here with our coupe, when we call cylinders, it imports sport. Sport, there's no cylinders here because it's extending classic. So it goes up to classic, and there we go. There's our cylinders 6, so which is why I can say true, and it's public because of the protocol that's been implemented. The complicated one to get your head around is going to be this horsepower RPM. So when you ask the coupe for this horsepower RPM, it's going to get the super, or the one that it extends. It's going to get the horsepower RPM from there, which was these two numbers, and it's going to do some calculations with them. And it's these two then that unify with the variables in the predicate head there. So make sure you can kind of see what's going on there, where this data is coming from, because there's a lot of layers here. You know, you've got the protocol, one category, an extended category, and the object. So it's 4 layers deep to see what's going on. But this kind of starts to really hint at the power of using protocols and categories together to create rich inheritance structures that let you write dry code. So, if you've enjoyed this episode of Log Talking, then please hit the like, subscribe, and the bell notification so that you get notified when new videos come out teaching and learning how to do log talk together. Until next time, happy log talking.